Okay, in this video I'm going to illustrate how I use several different optical components to create the cross-polarization photos of crystals I've been posting on my site. So, light source, I'm simply using a LED bulb in a desk lamp. I'm going to go ahead and just cover it with a piece of cardboard, white foam board, just to dim it down a little bit and give a diffuse background. This is a microscope slide which I have prepared, and it has some Epsom salt crystals that I've grown on top of it. You can see them if I just lay it down there. It doesn't look like much. They're pretty transparent. They're pretty thin. So you don't have the vibrant colors. In order to get the colors that you see in my photos, I'm going to take a piece of polarizer, and this is just the type of polarizing material that you would find on your sunglasses to reduce the glare from reflections off of metallic surfaces, water, so on and so forth. So if I place that on the light source and then put my microscope slide with the crystal sample on it, again, it doesn't really look dramatically different, just a little bit dimmer. Now I'm going to take a second polarizer and put it in between the camera lens and the crystal like this. And you can see the effect as I rotate the polarizer that I'm holding. You can see how it darkens the background and it makes the crystals and the crystal structure much more visible. Okay, and when I talk about cross-polarization as part of the technique, what I mean is I have two polarizers. Here, this is just a sheet of polarizing material, and this is just another polarizer in a circular mount. So if I place this one down on top of the light source, and I take the second polarizer and put it over top, you can see that if I rotate the second one by the right amount, it is now blocking all of the light from the source. So the two polarizers have their pass axes perpendicular to each other, and so the only light that gets through the bottom polarizer is polarized along one axis, but the second polarizer is set to block light, which is polarized along the axis that was passed by the first polarizer. If I rotate it by 90 degrees, you see all the light passes through. This condition is when the pass axes of the polarizers are in the same direction. So the cross-polarization technique simply refers to this effect when I cross the polarizers to block most of the light that's coming straight through, but you can see light making it through the crystals. And this is because of the birefringent properties of the crystals, which affect the polarization of the light that passes through them. So that some of that light gets rotated such that without the crystal in place, it would be blocked by the second polarizer, but it now passes because it was rotated as it passed through the the birefringent crystal. But you can see the colors they're there, they're subtle, but they're not the really bright, saturated colors that you see in my photos. These are pretty thin crystals, and to enhance the color in these crystals, I'm going to add a third component, which is another circular mount. This one is called a full wave plate, and this just manipulates the polarization more, similar to the birefringent crystal. So if I just, just placed the second polarizer in here now, you can see when the top and bottom polarizer are in the crossed configuration, the light which passes through the wave plate is still passing purple light. Okay, that's because the color purple is being rotated by the wave plate such that it will pass through the second polarizer. So now if I take my crystal sample and I place it atop the wave plate, which is atop the polarizer, you can now see the more intense colors. If I move this closer to the lens, you can see the whole effect. And here you can see how the left side of the slide and the right side of the slide, it's a good contrast to show the different effects with and without the different optical elements. And as you rotate this, I can make it so that predominantly yellowish light passes through the background. And getting all of the interesting colors in those photographs is really just a matter of rotating the crystals, the polarizers, the wave plate to various orientations, because each combination of orientations of the two polarizers, the wave plate and the crystals, will produce different combinations of colors which make it through the crystal into the camera. So that is how I have been producing those very colorful and beautiful photographs of crystals.